What you're missing, but the chances are higher that you may find, okay, what you are missing. And so that's sort of what the goal of puzzle-based learning is about. And so you got a little bit of a taste of that. The other thing that I like to discuss in any of my classes is that I tell them, frankly, like, okay, we're going to be together for 1 semester or 2 semesters there, and then you're out of this program, and 4 years of undergraduate, you're going to live to be 80 perhaps, and that's like 5%. 4 years of undergraduate is only 5% of your entire life. So what I really want to do is prepare you for what lies ahead later on. And fortunately, me and my students, we resonate very well in this. And one of the things that I highly suggest to them is just file away the name of this book. And sometime or the other, you need to spend some time with this and come to terms with everything that this book discusses. And one of the things is talking about begin with the end in mind. And what I wanted to do here at this point is just talk about the database curriculum that I teach from. Now, the curriculum itself is fairly standard. These are the various components that we have. But I think what makes this a little bit different from a traditional database course that you may see in a computer science program is that the whole thing is based upon what are the customer's needs. The whole thing is driven by that, and you start off with that. So you're starting off with how do we capture the customer needs from user stories? How do we develop a conceptual model? And I keep emphasizing to them that the whole thing about the conceptual model is about bridging this gap, because you now have 2 people involved. You got the developer and then you got the customer. Until then, in the curriculum, they are the only people who are dealing with the problem. And suddenly, they're in a context where now 2 people are involved, and what are all the various tools, that are utilized for that. Now, in order to cast this in more realistic terms, what the semester project involves is that these are some of the companies that have been incubated by a angel startup company called Y Combinator. And if you're not familiar with it, you can just go to ycombinator.com and take a look at it. And if you're not familiar with Y Combinator itself, many of the companies that you see over here would sound familiar to you. And what the project that my students have to do based on everything that they have learned in the course is I give them 2 companies. This time they're working with Uber and Airbnb. And I tell them, you need to identify 10 user stories. Take the Uber app, the one that you're very intimately familiar with. And what we're going to do is you're going to put on the hat as if you were a member of the original Uber team. The startup team that created the app for Uber, and you look at 10 user stories. What are the 10 most important functionalities that you think this application should do for you? Identify them, and then capture that, and then you're going to go end to end. You're going to build as much of the database as is needed in order to be able to support those 10 user stories, and that's what drives the whole thing. Now, to add in an innovative component to this, what I also asked them to do, which you can see that marked over there, is that you have to also identify something that the app does not currently do. So if you were going to tell Uber, like, this is another user story, another feature that I would like you to add to your app, what would that be? And then you implement as much of that. Now, you're just simulating the data, you're simulating the process and so on, but you're going through all of the motions that are needed for this. And that's the spirit of the whole course. And it goes back to what I was saying earlier, that one word, value. It's all driven by what is the value that you're going to deliver here. So what I don't do is spend a lot of time in terms of the various database algorithms, synchronization, locking, and so on like that, which you would traditionally see in a computer science course, but this takes on a very, very strong applied perspective. And this is the first time that I'm coming to DMZ, and from my various interactions, I've been very happy to sort of see, and I got some validation that what we're doing over there is what is in sync with what industry needs. But in addition to that, I'd very much like to hear from anybody who has views on what it is that you think that current graduates should know in terms of database technology, database modeling, and so on like that. My email is as simple as it gets. It's just raja@cmu.edu. So, and these slides will be available, okay, sometime later on. I'll pass it over to Steve, and they'll be available on the website. So if you have any thoughts about the curriculum or so, be sure to let me know. I'll see how I can incorporate that into our own curriculum, and then as part of my IS 2020 effort, I'll be happy to see whether we can actually fold that into the curriculum recommendation that we're going to make. Okay? So what I was telling people in the morning is that this talk is sort of like a Quentin Tarantino movie. It comes in 2 parts. And we have the part 1 in the morning, and this is a summary of okay, what it is that we did. What I'm going to be discussing now in the afternoon is separate from what it is. It builds upon it, but if you weren't there in the morning talk, it's not something that is going to hinder the comprehension of what goes on here. So one of the things that the question of modeling has come up, okay, obviously quite a large number of times, and one of the perspectives that I'm having here is that, okay, in database circles, okay, we tend to model so that we have a better understanding of what the domain is. It's about figuring out what are the business rules, okay, figuring out the domain constraints and so on. But when you go beyond that, okay, the modeling is meant not to understand the domain, but to understand the data. What is the data saying? Okay, and I'll give you some examples of that in a bit. And then once you have a better understanding of what the data is saying, what is it that we can do to reason with that data? Okay. We had a discussion in the morning about different aspects of AI and machine learning. These are some various machine learning tasks. Okay, they're sort of self-explanatory there. But one of the takeaways that I'd like to have is what's given at the box at the top as to what does it mean to learn something, okay, to quantitatively describe that I know something, right? For instance, the example that I was talking about today is that if you're going to make the claim that I know how to juggle, that I've learned to juggle, there's got to be a quantitative way in which you can measure that. And that measuring could be done by, like, how many balls are you able to keep up at the same time, or how long are you able to juggle before you drop a ball, or the complexity, juggling balls versus juggling burning torches versus running chainsaws. Okay, there's a difference in learned skill, okay, that you have there. So you need to have some performance metric of how well you're going to perform on a certain task. Okay, given the experience that you have with the task, and if you have more experience with it, if your performance goes up, then you can quantitatively say that learning has happened. Okay, and that's a way in which, okay, we are characterizing it. And then I went through some examples of this in the morning for classification, for optimization, as well as recommendation. Okay? But the focus of today is going to be on the realm of big data, because it has a very interesting implication with reference to the modeling aspect. Okay, so I'm going to talk about why are we where we are today, and then I also want to just give you a little bit of flavor of the types of things that a data scientist thinks about, and we'll do a very simple exercise again, where if you could team up, and we'll just spend about 5 minutes thinking about that, and then I want to go into a little bit more detail of what are the types of tools that we are using above and beyond what traditional database systems give you. And I'm not going to go into the technical details of this, but what I would like to convey is what I tell my students as the cocktail level of this. So if you're at a cocktail party and somebody asks, hey, what's the difference between Hadoop and Spark, or something like that? What is the intuitive feel, okay, that we have, okay, between these two? Then I'd wrap up with probably what is one of the most exciting things that have happened recent days. It goes under the umbrella of cognitive computing. And hopefully we'll have some time at the end for various discussions. So I want to start off with a few case studies. And we spent a lot of time and effort in terms of modeling. And a few of the questions